Right now we do 1.2 rate of change using equation. So looking at this graph, equation of the function f of x, y is equal to f of x, right? Means the y is the function of x. That's why the equivalent of the f of x is y. When we say f of b minus f of a is going to be your second y, f of a going to be the first y, f of a here. Is y2 minus y1 divided by x2 minus x1. Now, if you have an equation, you can use this formula to find the slope of the secant line between the 2 points. I can go to equation perhaps. That was average rate of change. Now for instantaneous rate of change, how do you use equation for instantaneous rate of change? For instantaneous rate of change, since we want to find the slope of the tangent line at one point, right? Let's say my point here is A. If I find a very close point to A in such a way that A and that point is approximately the same, let's say the second point, I really choose it close to A plus H. H gonna be very, very small, approximately 0. For example, you can take H to be 0.001. Then A and A plus H are almost identical. Then when you find the average rate of change between these two close points, it will give you a very good approximation about your graph. Okay, now these 2 points that is very close, I just show it here, but I know we put it at a very large distance. Just you imagine this is A plus H. So this point has the x of that is A and y of that is f of A. Here, A plus H, the x is A plus H and y is f of A plus H. So y2 minus y1, f A plus H minus f of A, as you see here. x2 minus x1, A plus H minus A. So A plus H minus A and A cancel. Then you have that equation, f of A plus H minus f of A divided by H. Make sure H is going to be very small number, like 0.001. This will be the instantaneous rate of change. Make sure when you do instantaneous rate of change, you have to find another point that is very close to your the point that you want to find instantaneous rate of change. We'll do an example. You'll see that better. Here, estimate the average rate of change from negative x equal to negative 3 to x equal to 2. So it's easy, y2 minus y1, the y at 2 minus the y at negative 3. So f of 2 minus f of negative 3 divided by 2 minus negative 3. So to find f of 2, whenever you see, so if this is your f of x, right? This is your f of x. You want to find f of 2 means instead of the x, anywhere you see x, just put 2. This is 3. Instead of the x, I put 2 minus 2 power 3. Then you evaluate that. See, you have it here. And f of negative 3, you do the same thing. Whenever you see x, you put negative 3, and you see that there. 2 minus minus 3, so it's become 2 plus 3. You put that in a calculator, you will find that average rate of change, which is negative 10. Now here, determine instantaneous rate of change at x2. So you want to find instantaneous rate of change. You need to find another point that is very close to 2, like what? 2.0001 is almost the same as 2. It's going to be f of 2.0001 minus f of 2, y2 minus y1, divided by x2 minus x1, 2.001 minus 2, it is 0.001, true? So then you have your equation, For f of 2.001, instead of the x, you put 2.0001. And for f of 2, instead of the x, you put 2 to find that. As you see is here, you can use a calculator to find the answer. Now, looking at the worksheet, the question I'm asking you to do is question 1. Question 1, A, B, and D. A, B, D. Question number 2, do part B. Question number 3, A. Question number 4A. Here, question number AI. 5AI and BI. Okay, that is the question you do on this worksheet.